In this lesson, we're going to take a look at some packet captures. Now, a packet capture is used to be able to capture all of the data going to or from a given network device. You can also set up a packet capture over a span port and capture all of the data going to and from all of the devices on your network, depending on how you configure your packet capture software. Now, when we look at a packet capture in this lesson, we're going to be looking at snippets because on the exam, they're not going to give you a full packet capture of gigabytes and gigabytes of data. But instead, they're going to give you something like 5 lines or 10 lines or 20 lines inside of a packet capture. And so that's what we're going to be focusing on here. Now, as we go through these 3 packet captures, I'm going to show you 3 different types of attacks that a threat actor might use against your network. Let's take a look at the first one. Now, in this first one, you can see this whole packet capture that I'm showing you only has 19 lines. Now, it's actually going to be the longest packet capture we're going to look at, but it's also one of the easiest. Now, as we look at these, you can see that we have a couple of different columns here going across the top. The first one that we have is what's known as the number, and this is the packet number in the capture sequence. So we started out with 1, then 2, then 3, and we went all the way down to 19. The second column we have is the time. When did this happen? Now you'll notice this isn't actually a date and time like you're used to, but instead it's actually written as the amount of time that has elapsed since we started the packet capture. So it's important to make sure you capture the time you begin your packet capture so you can then coordinate this as you bring this packet capture into your SIEM or other types of incident response systems, so you'll be able to consolidate this and correlate it across all of your different logs and devices, because just knowing that this happened at 0.002 seconds after the ability of us starting this packet capture isn't as helpful if we can't correlate that across all of our systems. The next 2 columns have IP addresses, and you'll see the source and the destination. Essentially, it's our perspective based on the sensor of what the data is coming from and where the data is going to. In this case, we have 2 sample IP addresses being used of 99.88.77.66 as our source, and we're trying to go to our destination, which is 11.22.33.44. Next, you'll see the column for protocol, and this will either be TCP, UDP, or something else. For example, if we're operating at layer 2, you might see things like ARP being used. But since we're here at layer 3 and layer 4, we're going to be talking about TCP and UDP. Next, we have length, and this is how long or how big that packet is, and all of them are only 74 in this case. And then we have info, which will give you some information that's being captured from the header of each of these packets. In this case, you can see the flag that's being set, and you can see here that that is the SYN flag, and we don't see any ACK flags or SYNACKs. And then we see the sequence, the window, the length, the MSS, the S port, which is your source port, and your D port, which is your destination port. So now I'm going to count down from 10 to 0. And when I get to 0, I'm going to tell you what type of attack we're seeing inside of this packet capture, but I'm hoping you'll be able to figure out in the next 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, did you figure it out? This is actually a port scan. Now, in fact, this is actually a port scan of the top 19 ports, and this scan actually was going on to the top 100 ports using an Nmap scanner. But in this packet capture, I only showed you the first 19. You'll notice the first port we're being scanned is the D port of 80, which is HTTP or the Hypertext Transfer Protocol. The second one is port 23, which is Telnet, which is an insecure version of remote access. The third one is port 22, which is going to be for SSH, which is a secure remote shell capability. The fourth one is FTP at port 21. The fifth one is port 443 with HTTPS, and so on. As you can see, each time a SYN packet was being sent, it was being sent with a single SYN and a port going to there to basically see if that port was open on the remote server, which in this case was the destination of 11.22.33.44, and it kept doing that over and over and over again so that my Nmap software was able to see are there any ports open as part of my reconnaissance during a penetration test. Let's go ahead and move on to our second packet capture. Now here is our second packet capture, and you'll see that we have a couple of dots in between. So as we're going down the first column with the packet numbers, you'll see I have the first 5 packets shown, then I skip down to packets 100 through 102, and then I skip down again to packets 1000 to 1002. All those dots are saying is there's other packets happening here, but I'm not showing it to you in this log snippet, and you'll see this used on the exam as well. As we go through, you can see that this whole packet capture happened within 0.1 seconds. So this is actually a pretty fast packet capture to get 1000 packets through. You'll see the source and you'll see the destination. Now, in this case, we're looking at the protocol as TCP, the length is 74, and again, we see a whole bunch of SYN packets there, and we don't actually see the port numbers associated with them. So If you are looking at this and you see all of these SYN packets happening from packet 1 all the way through to packet 1002 and continuing, because there's still 3 dots there at the bottom, what do you think this is? I'm going to go ahead and count down from 10 again and see if you can guess. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Did you guess it? This is actually a type of denial of service attack known as a SYN flood. Notice in this packet capture, we are not seeing any acknowledgments coming back from that destination server to our source, and we're not seeing any SYN acts going from our source back to our destination. So what we have here is the first step in a 3-way handshake, but the second and third steps are not being completed. Now, the reason I'm showing you this is because this is another type of attack that you're going to see commonly used in your logs, where an attacker will use a SYN packet as a way to start a half-open connection, and they won't finish the connection. When this happens, it eats up resources on that destination server, and eventually that server can actually crash if there's too many open requests. Let's move on to our third packet capture. Now, our third packet capture actually has over 3,500 packets, but again, I'm only showing you about 10 of them here, and I'm using a bunch of dots to be able to hide the fact that there are a bunch of things that are missing. Now, as we go through here, you're going to see it looks very similar to the last one, so you're probably thinking it's some kind of a denial of service attack, and you'd be right. Now, as you look through, one of the differences of this one versus the last packet capture is that we all have the same destination being targeted, but we're using different sources. Notice that the first 1,000 packets were all being used from 192.168.1.101. Now, they were trying to do a SYN flood as a denial of service attack, and it appears that that wasn't successful because the server was still responding. So they started bringing in other hosts as well to start sending traffic. So you'll see that the first one was 192.168.1.101. If we drop down to packet 1500, we can see that the source there is 192.168.1.102. If we go down to packet 2000, we see 192.168.1.103. If we go to 2500, we see 192.168.1.104. And every 500, we're going to another system and using a different IP address. So what this is showing us is this is a distributed denial of service attack where we have multiple systems all going and attacking the same server. Now, in the case of this packet capture, we can see that we had 3,500 packets being sent in about 1.75 seconds from across multiple different IP addresses. And so as we went into something at scale, you might see hundreds or hundreds of thousands of these packets from various IP addresses that are all attacking you as part of a botnet inside of this type of a packet capture. But what we're trying to demonstrate here is the idea that you could see a distributed denial of service attack inside of a packet capture. Now, for the exam, it is possible that you would get a packet capture that has 5, 10, 15, or 20 lines like this. And often, those people who already work in the field look at this and go, I don't have enough information to make a decision. And you're right. In the real world, I wouldn't call this a distributed denial of service attack just by seeing these 10 or 15 lines. But again, you have to ask yourself on the exam, what are they trying to show me in 5 or 10 or 15 lines? And the most obvious thing here would be that we have a distributed denial of service attack because we are doing these half-open connections to eat up resources on the same server, and all of the destinations are the same server IP, but the sources are coming from different places. So this would be a distributed denial of service attack. Whereas when we looked at number 2, all of the sources were one computer, and all the destination was one server. So that was a regular denial of service attack. Keep this in mind as you're taking the exam, and you'll do really well when you're looking at these packet captures.